Hi, everybody. I want to thank Dr. Schlachter and Schwartzberg for the opportunity to present and Sages for having this event. Let's see here. So today I'm going to take the next step here and try to get this to work. Green. Oh, there we go. Here are my disclosures. I think we have to wait 4 seconds. Oh, good. So again, we just heard from Dr. Azaguri about ideas and patents, intellectual property. After myself, we're going to hear from Mara about commercialization. But how do we get from that idea to a sellable, valuable product? So this right in here. So this is what we're going to try to talk about in the next 15 minutes. It's a lot. We're going to talk about how to assess value of your idea, of maybe your patent, what licensing is and how value assessment informs licensing strategy. Talk a little bit about seed funding, prototyping, and proof of concept. So just some high-level thoughts around innovation. So I think human beings are inherently creative, and I think that's a really wonderful part about us living together on the planet. So, you know, inventing stuff is great. What's the difference between invention and innovation? Well, invention is you come up with something. Innovation is you actually commercialize it. It's a product, you sell it. And so I think that is a good takeaway point for this talk. And then I saw this in George Bursey's autobiography. He is one of the early founders of Sages, an amazing innovator. If you haven't bought his book and read it, I highly recommend it if you're interested in surgical innovation, but all truth passes through 3 stages. First, it is ridiculed. Secondly, it is violently opposed. And third, it is accepted as being self-evident. So anyone in the innovation space, be prepared for ridicule, violent opposition, and maybe acceptance if you hang in there. So traditional innovation really was the 3 Ds, so diagnostics, drugs, devices. Also some things around quality and cost improvement and cost containment. Modern innovation has some of these similar elements. I'm just gonna throw in a lot of new things that have come down the pike in the past 20 years. Probably since COVID, telehealth is exploding. Apps in general. I think it's interesting that Peloton can track more data about me than a physician's app can, right? So in this sense, industry is a lot ahead of healthcare in terms of health tracking. Smart devices, the pedometers on our phones, the smart watches, bandages that may tell you if your device is or your wound has white blood cells in it. I think we're going to see more of that. Of course, the robot and the multiple robotic platforms we're going to be seeing. And then big data, all this stuff, all the data we're capturing in healthcare, how do we use it? So what are some reasons physicians are good innovators? Number one, I think most of us love learning, and there's a lifelong learning mentality amongst people who are physicians. We are dedicated, right? We care about helping people get healthier. And we're immersed for the most part in medicine, and usually we can see problems and solutions firsthand. Now, what are some reasons physicians might not be good innovators? Well, number one, there's very little training in business and engineering in medical school or subsequently. 40% of physicians are burnt out, and so when you're burnt out, I think it's hard to be creative. And healthcare is really dominated by these large companies, and so hopefully, you know, through this talk and learning on your own, you can learn how to navigate this space. So there's some talk floating around, I think, in the ivory tower around paths for academia. And traditional academia, as you know, is a trifecta of clinical work, education and teaching, and then research. Now, there have been some editorials written in the past few years around this idea of a clinician innovator, so a 4th path for physicians, people who are interested in the intersection of healthcare delivery and healthcare technology, This idea that maybe as an academic surgeon or a surgeon in general, you don't have to necessarily do the trifecta. You could actually do innovation as part of your contribution to medicine. And so I would say going forward in the next 20 years in academic medicine, I really hope that this track actually becomes real. So you could have people working with you and around you who are innovators, and you're going to foster that. And I think any directors of, chairmen, those sort of people should start thinking about including that in their surgery program. Stanford's biodesign is one of the few programs in the country that has that, and they are wonderful, but of course we need more. So back to the actual talk. That was my pep talk for you guys. So really, if you have one takeaway point from everything else I say, is that from the point where you have the patent forward, teamwork is critical. Absolutely and totally important. As surgeons, we are often seen as leaders of a team, and while I think that is very good, we also need to learn how to be team members. So listening without just waiting for the other person to stop talking so you can say what you were going to say. So become better listeners. I don't know if I'm that good at that, but I'm aware of it, Mara. And so value assessment, what does that mean? I'm actually just going to talk about two things I've been working on for the past 2 years. So on the left is this BAL simulator. So as I transitioned from my fellowship to my bariatric practice, in fellowship at Duke, we learned how to suture well with an endo-stitch device. I wasn't great at freehand suturing, and I said, how can I develop a tool to help myself freehand laparoscopically sew better? So I came up with this device. Basically, it's a holder. You can put 2 pieces of BAL on it. You can suture open. You can suture laparoscopically. An anastomosis. This could be a good training tool, I think, in the future for fellows. Especially as the volume of sleeves, at least in bariatrics, is going up and the bypasses are going down. So a lot of fellows, as they finish their training, aren't getting the 50 anastomotic cases they need to become bariatric surgeons, but I digress. So thought about this BAL simulator, also developing a fluorescent guided bougie for bariatric surgery. And so, when you assess value, you say, why is this idea valuable? For me, the one on the left is a great teaching tool. It could also be something that turned into an advanced FLS for SAGES, perhaps, and maybe another test that has a revenue stream for any agency giving it. It also has great ability to help someone learn to get past kind of the lower laparoscopic proficiency levels. Now, the valuable idea for a lighted bougie, really just to improve safety during bariatric operations. Now, when I ask, how can I build this? This is where the team comes in. You probably need to start talking with an engineer, having resources around 3D printing, those sort of things. How can I prove it works? That's kind of proof of concept things, and then what people or resources are needed. So backing up a little bit on definitions, licensing. So once you have a patent, you might want to license it. Again, a lot of text. I apologize. It's the boring slide. So what does it mean to license a technology? Basically, it means you have your patent for the wheel, and you work for Stanford, and so Stanford owns the rights to that invention. And so let's say you want to make something with this wheel. You need to get permission from Stanford to use that patent. Or let's say your friend has a company who wants to use the wheel. Their company needs to get permission from Stanford to use the wheel patent. And so the licensor would be Stanford, and the company or the person trying to make something from the wheel would be the licensee. And so again, value assessment informs licensing strategy. So very simply, for these two ideas that I've had, number one, the BAL simulator. I want to use it as an educational tool. I want the cost to be as low as humanly possible. I want that to drive people to actually want to try it. I don't want to sell a $500 simulator. Those robotic bellies, if you've seen them, where you put stuff into them, those are $3 to $5 grand just to buy that plastic belly, which is kind of unbelievable, right? So for this idea, I want it to be inexpensive. And with that, I probably don't want to start a company around it. I probably want to find a company. Let's say there's some companies that already make some synthetic bowel. They just don't have a stand. I might go up to that company once I have the patents done, right? I wouldn't disclose this before that was all finished. I'd go up to the company and say, hey, do you want to license this idea? You can make this, sell it. We'll create an educational curriculum around it, like a web curriculum, and you have this whole training in a box scenario. So that's kind of the smaller ideas. Maybe you want to work with a larger company that already is in that space. For this other license strategy for the bougie, well, this is where we create a company entity and license it back from the university. And so I tried to give two very simple examples. So let's just say with this simulator, we sell $100 worth of these simulators a year, and there's a 5% royalty. What that means is that the Stanford gets $5 of those sales, and usually the inventor gets a percentage of that $5, and the company who licensed it out or who got a license keeps the rest. Now for this, and so the inventor gets a small amount of $5, right? But it's being used. So for this, a company, so let's say we started a company to create this gastric calibration tube. Again, we make $100 in sales. Stanford gets a 3% royalty, but they also own 6% of the company as part of the license negotiation. So once again, when we sell this device, Stanford gets $3 in royalties. The company gets $97, but then of that $97, Stanford actually owns 6% of that. So that's just a different method. It is more complicated. It's more work up front, but the company and the inventor kind of make more money from this situation. Now, seed funding. So usually to build your prototypes, you need some sort of funding. It is hard to find. Pre-COVID, there were a lot of these launch pilot grants for innovation, and that's what I used for our device to get it off the ground. It was a $50,000 pilot grant. Some institutions have these little $5,000 seed grants. Sometimes that can cover enough to make a small prototype. Society grants would be the next place to look. So SAGES, ASMBS have $30,000 to $50,000 grants that are available, and that's a nice seed source. There's also something called the NSF I-Corps. It's actually a program where if you have an idea, you can bring it to them, and they help you kind of test the waters of commercialization. And there is some money at the end of that course. I want to say about 30 grand if you complete it. And finally, this is a large grant, something called an SBIR, STTR. These are actually $250,000 grants, usually given by the NSF, and I want to say NIH, but I don't think that's correct. And these are, for actually doing the whole first phase of a device. So that's a large amount of money. Now, industry grants, is that a good way to start? There's strings attached to that, right? So if you use an industry grant, there's probably a clause in there that says anything you invent during this grant, we might own a little bit of it. Also paying out of pocket, I think I would avoid that just because it's a slippery slope. So I'm gonna zoom past in the 50 seconds left of this lecture. Prototyping, again, now we're on the fun part. So prototype, yes, we made a 3D printed version of the simulator. We're still fine-tuning it to work perfectly. We made some 3D printed versions of our device, and now we're making a manufactured device. Proof of concept for a simulator, not so hard. You sew it, that's actually pig bowel. You leak test it with the manometer, it works for the most part. Proof of concept for a device, you can start ex vivo as we did with ours. So we used dead pig stomach and kind of got the idea. You can see we're experimenting with near infrared guided measurements on the bottom of both pages. And then we had to do pig and cadaver. So finally, what can you do? Just to conclude, get comfortable working as a team member. It's through teamwork that I think all of innovation can thrive. Being able to kind of ask all the questions on this list, start practicing in your work. Are there things you see that aren't efficient? Could they be done better? So just to wrap up, this is a summary of kind of the tech transfer, the innovation budget in our country. You know, a lot of research expenditures, 17,000 patents in 2018. So it's out there, and that's about it.